My name's Ed Lisinski. I'm the actually Midwest Regional Director now for American Wood Council, um, which means I'm based out and I'm on these all the time. So you guys have probably heard my spiel before, but I'm based just across the side of the lake from you guys over in Wisconsin in the Milwaukee area. So we have the Ascend Tower over here. A lot of great mass timber projects going on over here in Wisconsin, as well as Michigan, of course. Um, but my role with the American Wood Council, what we do, we write all the codes, the standards for all wood construction, including mass timber and heavy timber. Um, we're actually going to be down in Orlando in a couple weeks for the writing the 2027 I codes. So that's going to be a fun couple weeks. Hopefully, some of you guys can make it down there if you have any interest in seeing how the codes themselves are developed. So we do all the code writing, the standard writing, all that type of stuff for wood construction in general. Um, but also my role here is also to work with the building officials, the fire officials that are out there. So if you're out in a community, you're trying to do any type of wood construction, really, you start running into some issues with building officials or fire officials. Feel free to have them, reach out to me. It's usually better that way, if they just reach out to me and then we can talk about, talk through, whatever issues, concerns that they have. I also do, free training for them. So always available to help out anything there and anywhere in the upper Midwest here. I've got a 13 state region. So anywhere around here, if you're doing something, in Indiana, Ohio, Illinois, Wisconsin, wherever you're at, I'm sort of your guy. So with that, what Sandra asked me to talk about today is obviously I'm sure you're aware, Michigan adopted their new building code, which is based off the 2021 IBC. That's going into effect in about 2 weeks from now, 2 or 3 weeks from now, April 9th. So you guys are going to have a brand new building code. What the 2021 IBC is what the significance of that is that's where mass timber first came into the code. So there's obviously heavy timber that's been around forever. Mass timber and all the mass timber provisions just came in for the 2021 code. They got further expanded in the 2024. We're hopefully trying not to take some steps back for the 2027, but I'll touch base on that a little bit later on. Yeah, so today I just want to go through the actual code requirements, let you guys know what's in the code, how to apply that, a little bit about the backgrounds of where that came from, that we'll do right here in the very beginning. This class actually is a full day class. I just really pared it down, so don't worry, I'm not going to keep you here for 8 hours, but I'm really just focusing in on the code requirements. There's a lot of design, structural design, fire design, stuff like that I kind of took out of this presentation. If anybody has questions on that stuff, feel free to reach out to myself. Anthony's another great resource with WoodWorks. We can certainly help you out with that side of it. But again, I just wanted to focus in on the code itself for this presentation, and mostly on the building code itself, right? I'll touch on the fire code a little bit towards the end. And we'll talk about that just a little bit, but all right, for some reason my screen did not advance. All right, here we go. All right. So a little bit of background as to where this stuff came into the code, just so you guys have that. 2015, the ICC started to look at mass timber and heavy timber over in Europe, starting to go bigger, taller with their woods. So December 2015, they put together an ad hoc committee on mass timber on tall wood buildings. That committee had everybody in there, architects, engineers, fire safety specialists, building officials, fire officials, pretty much everybody from all walks of life, including other materials, so concrete, masonry, steel, they all had people in there as well. They met over a course of a couple of years, just studying mass timber, studying heavy timber, trying to figure out, does it make sense to put this into the code? They came up with a whole bunch of different provisions, did a whole bunch of fire tests on that. If anybody's interested in the fire tests themselves that kind of proved what they went into the code with, that was actually done by the U.S. Forest Products Lab. They supervise the testing. We have the reports, all the fire tests on that stuff, plus a whole bunch of other fire tests out on our website. So you can find that pretty easily. If you can't find it, let me know. But again, if you're talking to a building official and they're just like, man, I just don't understand, how this stuff got into the code, how this stuff works. Again, you can contact me, but you can also direct them out to our website, show them all the test reports and fire test videos from that kind of proved what went into the code and how that actually all works. So, they had a bunch of objectives of that group. They wanted to make sure, the buildings weren't going to just burn down and collapse if the sprinklers didn't go off. They wanted to make sure that fire department had access to the buildings, a whole bunch of different things. But one of the objectives that group had was that everything that they put into the code, they wanted to make sure they had a fire test that they could, hand out and just sort of say, here, this proves that this works. And so that's what that whole series is. So that's all with ad hoc committee. Again, they kind of came in there with 17 different code change proposals, some Group A, Group B stuff. If you're familiar with how the ICC code process works, they came in with 3 brand new types of construction, new heights and areas and number of stories, multiple fire safety requirements, some requirements for safety during construction as well, which we'll talk about towards the end here. And then some exterior wall tests and things like that. But I think because they had so much involvement, all 17 proposals that they put forward all went into the code as recommended. If anybody's a glutton for punishment, if you want to go back, they do have the hearing videos, all the hearing documents, all that stuff. You can go back and watch those videos if you're ever interested, or if you can't fall asleep at night. These are those code change numbers for the Group A and then for the Group B. But again, we'll go through what these all are a little bit as we go here. So first off, we'll start off with definitions, and this one I always have to throw this out there. We have MassTimber at Michigan State. We use MassTimber quite a bit. The actual when you go into the code, the actual definition of MassTimber is structural elements of type 4 construction, primarily of solid built-up panelized or engineered wood products that meet the minimum cross-section dimensions of type 4 construction. The most important part of that is structural elements of type 4 construction. So you can use heavy timber throughout the code. You can use heavy timber in type 1, 2, 3, 5 construction, as well as type 4 construction, of course. But if you're using it in type 1, 2, 3, or 5, it's technically heavy timber in the code. If you see a provision that says mass timber in the code, you're only talking about a type 4 building. So a lot of the buildings that we see, they're type 3 or they're type 5, but they're utilizing heavy timber elements. They're using CLT, glulam beams and columns, things like that. While a lot of people will call those mass timber buildings, and they're utilizing the same products as mass timber, they're technically heavy timber buildings, unless it's a 4A, 4B, or 4C, which is the 3 new types of construction that we'll get into in just a second. That's when you actually have mass timber. So do keep that in mind. If you're going through the code and you see that term mass timber, you're now referring to that's only pertinent for type 4A, 4B, and 4C construction. Anywhere that you see heavy timber, you can utilize that elsewhere throughout the code. All right, so I prefaced it a second ago, but with the 2021 code, 3 brand new types of construction, 4A, 4B, and 4C. There's no changes to the old traditional type 4 buildings, but they did rename that as 4HT. So that's still out there. And again, heavy timber can still be used throughout. The only change on 4HT, I can't remember if I left it in here or not, because it's not really pertinent to the mass timber stuff, but for the old traditional type 4, which is now 4HT, everything's the same, height, area, materials, all that stuff is exactly the same. The only difference is that you can have concealed spaces in there now. So if there are any designers out there who do traditional type 4 construction, which is now 4HT in the new 2021 code, you can have concealed spaces. You do have to protect them. Gives you 3 options. It's the same 3 options as what's in NFPA 13. So you've got dropping a sprinkler head into that concealed space. You can fill it solid with non-combustible insulation, or you can protect all the combustible surfaces in there with 1 layer 5/8 type X gypsum. But you can now have those concealed spaces. That's really the only change to Type 4, the old traditional Type 4. Here's a little side-by-side comparison of those three new types of construction, though. So Type 4A, that's going to be your biggest, tallest type of buildings. But the unfortunate thing with that for wood lovers, 100% of the non-combustible or of the wood surfaces have to be covered up with non-combustible protection. So you're not going to see any wood when you walk into that 4A building. I get asked all the time, why would somebody build to that? Well, there's still tons of obviously environmental benefits, with sequestered carbon and things like that. There's speed of construction. There's lighter foundations. There's just, obviously, I'm preaching to the choir here, but, a lot of benefits of still building with wood, even if you can't see that wood. But that's going to be your biggest, your tallest buildings that are out there. Type 4B, 100% non-combustible protection on all surfaces with some limited exposed mass timber elements. So now we can have some ceilings exposed, some walls exposed, some individual columns exposed, some things like that. We'll talk about when and where and how much you can do as we go through this. But that's sort of your 4B buildings, and then your Type 4C, all that wood can be exposed, with three exceptions. There's the interior and exterior of shafts still have to be covered up with some non-combustible protection. The exterior side of exterior walls has to get covered up, and then concealed spaces again have to be covered up with some gypsum in there. So, but otherwise, for the most part, all your walls, all your ceilings, all your columns, all your beams, for the majority of the interior of your building in Type 4C, you can leave all that wood exposed, which is beautiful. But then obviously that's going to be your shortest and your smallest out of these three new types of construction. The permitted materials throughout, you can use mass timber or you can use non-combustible elements, but it has to be of those mass timber sizes. If you think back to that definition, so if you're going to use wood anywhere in these buildings, it has to meet those minimum sizes structurally. It has to meet those minimum sizes of heavy timber construction. Which, for a column it's typically a 8x8, for a beam that's typically a 6x8. You can go a little bit smaller if you're only supporting a roof. And then there's equivalencies for glue lams and structural composite lumber in that table 230411. But for the most part, though, it's got to meet those minimum sizes. You're not going to get any 2x4s, 2x6s, anything like that. They have to be, those heavy timber sized elements if you're going to have any wood in those buildings. Even for non-combustible partitions or non-load bearing partitions, you can't use 2x4s, 2x6s, anything like that. You can't use fire retardant treated wood right now in the code. It's so you're either going to have obviously some larger members, or else typically what people will do is steel studs and gypsum for interior partitions then. So again, mass timber meeting those heavy timber sizes or non-combustible structural elements and interior exterior walls. Down there towards the bottom, the shaft and exit enclosures, Type 4A buildings. Once you get above 12 stories, it's got to be a non-combustible stair and exit enclosure shafts. But otherwise, at 12 stories or less, you can use mass timber or non-combustible, and then same thing with Type 4B and 4C. And we'll talk about each of those sort of as we go. One last little side-by-side comparison. Again, Type 4A, non-combustible protection throughout. 4B, some limited exposure. 4C, pretty much you can leave all your wood exposed. And we'll dive into a little bit more detail on each of these three types of construction. One thing I will mention it because I just reminded myself by seeing the picture in the lower left-hand corner here. ICC and AWC, we did produce a mass timber buildings in the IBC guidebook that's out there. You can buy that on ICC's website. I think it's about $35 or so. It's a great resource. A lot of the graphics that are in this presentation were used in that book. We're working right now on a supplemental guide for the 2024 mass timber provisions that you could slide into that book. I think we're going to offer that for free, but don't quote me on that. It might cost you a couple bucks, but if Michigan ever goes to the 2024 code, even if you buy a book now, it's going to be that same book, just with some insert pages for the 2024 codes. So, if anybody's interested, feel free to purchase that right away. All right, definitions, let me jump back to that. I mentioned it a little bit, but non-combustible protection for mass timber. So that's non-combustible material in accordance with section 703.6, designed to increase fire resistance rating and delay the combustion of mass timber. Non-combustible protection for mass timber is going to be very, very important throughout the code. It's typically going to be 2/3 of whatever your fire resistance rating is, but we'll take a look at that in just a second here. But again, this is just for mass timber. It doesn't apply to heavy timber if you're using that in any of those other types of construction. So how do we come up with that amount of fire resistance protection that we need? Chapter 703.2.2 gives you all the different methods for establishing fire resistance in the code. One of those is fire resistance per section 722. That's all the material specific stuff, right? So concrete, masonry, steel, they've got their own sections in 722, as does wood. So one of those sections that was brand new in the code, 722.7, fire resistance rating of mass timber. So I'm going to read this to you, but again, the required mass timber required in 602.4, that's your occupancy chapters or your types construction chapters, shall be determined in accordance with 703.2. That's what we just looked at. That sent us here. The fire resistance rating of the building elements shall be, as required in the code in 601 and 705.5. For the designers out there, if you're not familiar with table 705.5, that used to be table 602. That's your fire resistance rating of exterior walls based off of fire separation distance, right? They moved it into chapter 7 with the exterior wall requirements. So, as you're moving into the 2021 code, you'll see that table moved from chapter 6 into chapter 7 in 705. So that's what that table is if you're not familiar. The fire resistance rating of the mass timber element shall consist of the fire resistance of the unprotected element added to the protection time of the non-combustible protection. So as you guys are all aware, mass timber or heavy timber itself has some inherent fire resistance rating to it and some fire resistant qualities to it. So you're going to add, how much mass timber itself has some fire resistance qualities, and then you're going to add the amount of protection given by that non-combustible protection to that, and that's going to be your fire resistance rating, of course. So it goes on to talk to 722.7.1, which is your minimum time that's required. So we're established by 602.4.1 through 602.4.3, and that's your 4A, 4B, and 4C construction. Non-combustible protection shall be provided for mass timber in accordance with 722.7.1 parent 1 with that table. So let's take a look at that table in just a second here. Actually, yeah, here, let's take a look at that table. So here is, your fire resistance rating based off of table 601 or 705.5, and then how much non-combustible protection you have, how much of that gypsum that you need to put on there. So if you have a 1-hour wall, you need 40 minutes of non-combustible protection, of gypsum protection on there. If you've got a 2-hour column, you need 80 minutes now of non-combustible protection. And I say gypsum, but that could be any type of non-combustible materials that are installed on there. And then if it's a 3-hour floor, 3 hours primary structural frame, 120 minutes is going to come out of that non-combustible protection then. So you'll notice that 2/3 ratio. You'll see that throughout the code. 2/3 is going to come out of the non-combustible protection. 1/3 is going to come out of the mass timber itself. So moving on to 722.7.1, the second sentence in there, the rating in minutes contributed by the non-combustible protection shall be established in accordance with 703.6. So 703.6 is going to give you a performance method of coming up with that non-combustible protection. So basically you're going to run an ASTM E119 test, one test with the just mass timber on its own, and one test with the mass timber having a non-combustible protection, whatever you're trying to test. If the mass timber on its own burns out in 3 hours, the mass timber with the non-combustible protection on it burns out in 4 hours. You compare the two times, 4 hours minus 3 hours, whatever you put on that mass timber provided 1 hour of protection, of course. So that's the performance method. You can go through that and say, whatever we applied to that, that's going to give me 1 hour, or that's going to give me 40 minutes, or whatever that time difference is. And you can then put that into that table that we just looked at. Not a lot of people are going to do that. It's obviously expensive, time consuming to run two ASTM E119 tests or UL 263 tests. But that is an option out there. It might be an option for newer products that come onto the market that aren't recognized by the code yet, or might not have a ICCES report yet. The last sentence, though, of 722.7.1 says the protection contributions indicated in table 722.7.1 parent 2 shall be deemed to comply when fastened in accordance with 722.7.2. So let's take a look at table 722.7.1 or 722.7.1 parent 2. That's going to, again, be a deemed to comply table. And that's going to give you a prescriptive option here, where 1/2-inch type X gypsum is going to give you 25 minutes and 5/8 type X gypsum is going to give you 40 minutes of protection. Now, if we compare those two tables together, kind of makes it really obvious here of what everybody does with this. If you need a 1-hour wall, you need 40 minutes of non-combustible protection. Well, one layer of 5/8 type X gives you that 40 minutes of protection. If you need a 2-hour column, 80 minutes of non-combustible protection. Well, 2 layers of 5/8 type X gives you 80 minutes of non-combustible protection. 3-hour primary structural frame gives you 120 minutes, and 3 layers of 5/8 type X gives you 120 minutes. So, if you need a 1-hour fire resistance rating, put on 1 layer of 5/8 type X. 2-hour fire resistance rating, 2 layers. 3-hour fire resistance rating, 3 layers of 5/8 type X gypsum, and you're good to go. And again, then you don't have to go through any of that testing or anything like that. That just gives you that prescriptive option in the code of how to comply with that fire resistance rating. Now, it did say that you have to install that correctly per 722.7.2. These are some of the rules that are in there. There are a couple others, but screws that to penetrate 1 inch into the mast timber. That non-combustible protection has to be tight to the mast timber itself. And then, those screws have to penetrate at least 1 inch into the mast timber. Screws shall be spaced no more than 12 inches on center in each direction. The tricky one on that is when you get into a second layer, the screws from one layer to the next layer have to have at least 4 inches of separation between them. They can't be closer than 4 inches to each other. So 12 inches on center for one sheet of gypsum. When you have that second layer on there, though, now you need at least 4 inches on center minimum separation from one layer to the next. How do you do that? Good luck, obviously, but for the contractors that are out there, it's really just laying out your screw pattern, making sure that your contractors are aware of that rule. Make sure that they're probably going to have to measure out where those screws go. Obviously, if it's only 2 layers, you can go 6 inches on center. And you've got a couple inches of leeway in each direction, but just making sure that your drywall contractors are aware of that. Screws at the panel edges between 1 to 2 inches from the edge. Panel offset from one layer to the next of gypsum has to be at least 18 inches. So again, once you get into 2 or 3 layers, and that's just from that adjacent layer. So you're not worried about that 18-inch offset from the first layer to the third layer if you have 3 layers in there. You're going to have a stair step profile. We'll take a look at all that. And then the screw heads, panel joints, everything covered up with joint compound. One other thing that's not on here, when you do have that third layer, you can put some furring strip in between the second and the third layer to give you a little bit of space there, which is sometimes helpful. So here's what that looks graphically. Again, you can see the solid line. This is like a reflected ceiling plan. That solid line is the first layer of gypsum. The kind of dotted line is the second layer of gypsum going on. The dots on that first layer are the first layer screws. The X's or the stars are the second layer screws. So you'll notice, again, you have that 4-inch offset from one layer of screws to the next. Again, make it 6 inches, make it easier on yourself. But then you have that 18-inch offset from one panel edge to the next on adjacent layers. You'll see on the sort of a wall detail there in the corner on the right-hand side. We need that stair step profile into the corners. So if you need 2 layers of gypsum on the walls, do the first layer on the east wall, then the first layer on the north wall, your second layer on the east wall, your second layer on the north wall. You can't go, first layer, second layer of the east, and then first layer, second layer of the west, or of the north, I should say, because they don't want that seam that goes all the way through. They want to make sure that you're covering up that seam as best you can. Same thing on the ceiling. This is a sort of a section detail of a wall and ceiling intersection. Most contractors, they want to do, obviously, both ceiling layers first, if everything needs 2 layers. Do both ceiling layers first and then both wall layers. But again, they want that stair step profile. So first ceiling layer, first wall layer, second ceiling layer, second wall layer. You have to step those through like that. So, and again, that's all detailed in 722.7.2 in the code. And that's if you're going to use that prescriptive option. So if you're not going to use that, if you're going to go through with the performance option, then it's going to be how that was tested and how how that product itself works. I see a couple questions popping up, but I'll take those at the end. But definitely, kind of get those in as you're going through. 722.7.2.2 talks about exterior surfaces. So I mentioned that with the 4C, but also 4A and 4B. All 3 types. When you have an exterior heavy timber or mass timber, like a CLT panel or something for your exterior wall, that all has to get covered up with at least 1 layer of 5/8 type X. And so you're going to have, there's some nailing pattern or screw patterns for that as well. 12 inches on center in the field, 6 inches on center on the joints and ends, and then some requirements for those exterior screws. All right, the fire resistance rating, we talked about this a little bit, but here's what those ratings are. So 4A, 4B, 4C added to table 601. What you'll notice here, I sometimes have some graphics on this, so I must pull those out. But what you'll notice here is where they came up with this stuff. The type 4A, that actually matches type 1A for fire resistance rating. So for the designers in the room, when you think about a type 1A building, that's your unlimited area, unlimited story, skyscraper, everything's completely non-combustible type buildings, right? When you think about that level of fire resistance ratings that you have in that building and that level of fire resistance protection that you have in a type 1A building, that's exactly what you have in a type 4A building, right? So you've got 3 hours on your primary structural frame, 3 hours on your bearing walls, 2 hours on your floor construction, and 1.5 hours on your roof construction. The provisions for the 4B and 4C were all taken from type 1B. So you'll see those all mirrored over. 2 hour fire resistance rating on your primary structural frame, 2 hours on your bearing walls, 2 hours on your floor, and then 1 hour on your roof construction for those. And again, that's your fire resistance rating is going to come in. Whether or not you have that non-combustible protection. We'll talk about that sort of as we go. Again, the former table 602, but now table 705.5, your fire resistance rating of exterior walls based off of fire separation distance. You'll notice that 4A for a 5 to 10 foot fire separation distance gets lumped in there with 1A, and then 4A and 4B get lumped in there with 1A and 1B as well. All right. So exterior walls, we'll take a little cross section here of each of these different types of construction here, starting with the 4A. This is a exterior bearing wall. So again, if you recall back here, exterior bearing walls are going to be 3 hours for type 4A. So you'll have on the interior side 3 layers of 5/8 type X gypsum, and that's going to provide 120 minutes of the 3 hour protection. The other 60 minutes that's coming out of there is going to come out of the CLT itself, or the heavy timber element that's in there. So 2/3 that's going to come out of that non-combustible protection. Again, keep in mind that you have 1 layer of 5/8 type X required on the exterior side of exterior walls. And like I mentioned earlier, between that second and third layer, you can do a furring channel if you want to on that. Might be a good way to slide in a little bit of insulation, maybe hide some electrical conduit, things like that. But you are permitted to have that furring channel in there. Keep in mind, if you are closer than 10 feet to a fire if your fire separation distance is less than 10 feet, now you're also worried about fire coming in from the outside. So you would have 3 layers of gypsum on the exterior side of that exterior wall as well. One thing I will mention while we're at it here, and I'm sure a lot of the designers are aware, we're going to talk about the CLT as an exterior wall. A lot of times in Michigan, same thing in Wisconsin here, just because of our climate zone and stuff. Typically, you're going to end up with a typical curtain wall system on the exterior walls, just so you can get that insulation value. I think I pulled that out of this presentation, but when you get into the energy code, if you have a thick enough CLT panel on the exterior wall, you can get into a mass wall situation where you need a lot less insulation on that. But for the most part, though, if you have a thinner CLT panel out there, you're not going to qualify as a mass wall, so you're going to have some decent insulation on there. Again, you can't obviously put it in that wall, and you need that non-combustible protection to be tight. You also can't have any combustible elements outside of the CLT other than a water-resistant barrier. So you can't put any combustible insulation on the outside. So again, that's where you'll get a lot of curtain wall system, your typical curtain wall systems on the exterior of buildings up here in the northern states. But you still could possibly do it though with CLT. I don't want to discourage you from that. Yeah, type 4A, we'll jump through that. Here's sort of a mock-up of what that 4A is going to look like. We'll go through each of these a little bit more with how much height and area and stuff you can have. But again, all the mass timber has to have the non-combustible protection, interior and exterior. And then floors do have to have a minimum 1-inch non-combustible material on top of the mass timber. I didn't mention that earlier, but there is a requirement in 4A and 4B for a 1-inch non-combustible material. Now that can just be lightweight concrete, gypcrete, something like that. It's different from that non-combustible protection that's required. This is just a non-combustible material. It doesn't have to be tight. You can have some insulation in there as well if you want to. But again, that's a requirement in 4A and 4B. Your 4B exterior walls, I'll jump through these kind of quick because it's real similar to the 4A, but now it's a 2-hour exterior bearing wall. You can have your 5/8 gypsum, 2 layers on the interior, 1 layer on the exterior side of the exterior wall. And you can also have some exposed wood elements now on the walls that we'll talk about in just a second. This is what sort of that looks like. Again, interior mass timber can be partially exposed. You've got non-combustible protection in certain areas, typically going to be 40 minutes of the mass timber itself or the heavy timber, and then 80 minutes of the non-combustible protection. And then again, you've got that 1-inch non-combustible material on top of your floors. I've mentioned it a few times that you can have some exposed areas in type 4B. How much are we talking about? So you basically have 4 options here in the code. The first option, unprotected portions of mass timber ceilings, including attached beams, shall be permitted to have a fire, shall be permitted and shall be limited to an area equal to 20% of the floor area in any dwelling unit or fire area. So let me break this down just a little bit here, because there's actually a lot going on in that sentence. So just sticking with 1.1 right now. So unprotected mass timber ceilings, including an attached beam. So if you've got that ceiling and you've got a glue lam beam that's tight to it, that's included in your ceiling area. So that 20%, you have to take the surface area of that beam and include that into your 20%. Now it shall be permitted to an area. Now in the 2021 code, it does say limited to an area equal to 20%. The 2024 code, they clarified that to say equal to or less than 20%. The way it's written right now, it almost says that you have to do 20%, but I think it's reasonable for any building official out there to think that you can have a little bit less than that too. So, but again, the 2024 code clarified that it's equal to or less than 20% of the floor area in the dwelling unit or fire area. All right. So again, it's not the area of that room, it's the area of the dwelling unit or the fire area, which means obviously, if you have a large enough fire area, you could go into a conference room or a couple offices, and that whole ceiling in that office or that conference room could be exposed mass timber because you're less than 20% of the entire area, right? Same thing in a dwelling unit. The whole bedroom could probably be exposed, as long as that bedroom is 20% or less of the area of that dwelling unit. 2024 code as well that did clarify to say that It's of each floor. So if you have a two-story dwelling unit, you can't take all the area on the first floor, all the area on the second floor, take 20% of both of those and put that all into the first floor. It's, you take your first floor of the dwelling unit and put 20% in that ceiling, take your second floor area of the dwelling unit and put 20% in the ceiling of that floor. So that was also clarified in the 2024 code, but not in the 2021. What's also in the 2024 code, a lot of you may be aware of this, but that 20% actually was increased to 100%. So you can do 100%. Now, are you always going to get 100%? Probably not, because there, toilet rooms, mechanical rooms, things like that, where you may want that ceiling to be covered up, stair shafts, things like that, where you're required to. But again, but you're even if you have a slope ceiling in some areas or mezzanine areas, so you may not always get to that 100%, but or you may be less than that 100%, I should say. But that's in the 2024 code, not in the Michigan code yet. I just want to clarify, you guys are stuck with the 20% for now. But if but there have been a lot of people, not necessarily in Michigan yet, but throughout the country, who have gotten variances to build to the newer codes and to build to the 2024 codes. All right. 1.2. So option 1, put it all in the ceilings. Option 2, put it all in the walls, right? So unprotected portions of mass timber walls, including attached columns, shall be permitted, again, with an area equal to or less than in the 2024 code, 40% of the floor area in the dwelling unit or fire area again. So now we're talking about that wall, and if you have that column that's attached to it and tight up against it, they don't have to be mechanically attached. What it's really referring to is up against that exterior wall or that interior partition. So your mass timber or heavy timber wall, having that column right up against it, that would also then be included in your floor area. So option 1, put it all in the ceiling. Option 2, put it all in the walls. Option 3, do a combination of a little bit on the ceiling and a little bit on the walls. And that's just going to be a ratio. We'll look at it in just a second of what you're permitted to have on the, or what you want to have on the ceiling divided by what you're permitted to have on the ceiling, plus what you want to do on the walls divided by what you're permitted to have on the walls. And that ratio has to be equal to or less than 1. So put 50% of what you're permitted on the ceiling, put 50% of what you're permitted on the walls, and you're going to be good that way too. So option 1, all on the ceiling. Option 2, all on the walls. Option 3, a combination of those. And then the fourth option is columns and beams that are not an integral part of walls or ceilings can be unprotected without restriction. So if you have that column in the dead center of a room, that you can leave that exposed, and that does not take away from your ceiling or your wall areas that you're permitted. So that's sort of your 4 options of what you can have left exposed in those 4B buildings. Those fire tests they talked about earlier on, this is what when they were testing they tested out, obviously having some of these ceiling areas exposed. That's what that looked like. But we'll take a look at some examples here. So this is an area of 20% of the floor area being exposed up on the ceiling. This is if you split that into 2. Now we've got a area of 10% of the floor area and another area of 10% of the floor area. That adds up to 20% of the floor area, and you can have that, of course, on your ceiling as well. Here's a total of 40% floor area exposed on the walls. You've got a 20% on one wall. You've got another 20% on the other wall. So here's that. Calculation that I was mentioning earlier about option 3 that's in the code. So your mixed unprotected areas, you'll see that equation right there in the middle. It's your unprotected ceiling areas divided by your allowable unprotected ceiling areas, and then your unprotected wall areas divided by your allowable unprotected wall areas being equal to or less than 1. So again, here's 50% of what you're permitted on the ceiling and 50% of what you're permitted on the walls. This would be just fine as well. And I'll mention too, this is, assuming that this room is one big dwelling unit, basically, right? Or fire area. All right, so here we go again. It's a 30 by 30 room. So we have a 6 foot by 30 foot area up on the ceiling, and that's 20% of your ceiling area. So that's going to be fine. You'll notice that you have that column that's attached to the ceiling. that's got to get covered up then, because right now the ceiling takes up that full 20%. Again, yes, this one to this one, the area doesn't look the same that's exposed on the ceiling, but it's still dimensioned as 6 feet. So again, you can have that one-off column in the middle of the room exposed, and that does not take away from your ceiling area or your wall area that you can have. You can still have that exact same amount of ceiling area exposed. But now if you have that beam exposed, well, now you've got, a 12-inch by 18-inch beam in the center there. So you've got, a 1.5 foot on one side of that beam, 1.5 foot on the other side of that beam. That's 3 feet. You've got 12 inches on the bottom side of that beam. So that's 4 feet times that 30-foot length. And so now you only get 2 feet of your actual ceiling that you can have exposed. So again, you have to take into account the area of a beam that's touching the ceiling. If that beam was lowered, so it was kind of cutting through the dead center of the room, you could leave that exposed and then still do your 6 by 30 area up on the ceiling. But yeah. And then again, 2 foot, you've got that beam, and then that column, because it's one off, is not going to detract from that. Now there is a separation distance between unprotected mass timber elements. So between ceiling and ceiling exposed areas, or wall and wall exposed areas, or wall and ceiling exposed areas, you need a 15-foot separation between exposed areas in 4B. I will say that in the 2024 code, ceilings have been taken out of this. So it's just a 15-foot separation between a wall section and a wall section. So if you are going to try and get a variance to meet the 2024 code, you just have that wall-to-wall separation of 15 foot. While I'm talking about that, I will give out one little plea. If anybody is going to go down to the code hearings for ICC for the 2027 codes down in Orlando in a couple weeks, the concrete industry, they actually put in a proposal now to put ceilings back into this and to cut that ceiling area back down to 20% instead of the 100%. So there is going to be a pretty good debate about that. Obviously, concrete industry, they've got their own reasons for that, but they say that they have some testing that shows that 100% is wrong, and that not having that 15-foot separation for ceilings is wrong. We're obviously going to fight it, but if anybody else is down there and they want to help in on that, feel free to let me know, and I can get you the hearing numbers and all that stuff. So concrete is attacking mass timber as we speak for the 2027 codes. But anyway, 2021 code, though, you do still have the ceiling area exposed, needing that 15-foot separation. So again, if you have two ceiling areas, 15-foot separation between them, it seems kind of dumb when you think about it, right? You can have one big area, but as soon as you split that into two areas, now you have to move them apart. What's the difference? But it's in the code. Same thing, a ceiling area to a wall area, you need that 15-foot separation. So again, this is what's in the 2021 code. Again, 2024 code, you don't have to worry about this with the ceiling areas. The only thing in the 2024 code that you do have to worry about is this situation. So a wall to a wall exposure, 15 foot. And again, that's only in 4B. 4C, you can have everything exposed. All right. So we'll jump through here. 4C, again, everything can be exposed in those. So this is what that kind of looks like side by side. You don't need that 1-inch non-combustible topping on the floors there. So you could leave those floors exposed if you want to in a 4C. You don't have to have any non-combustible protection on the interior, but you do still need your 1-layer 5/8 type X on the exterior side of the exterior walls. And again, I mentioned this earlier, but all material outboard of the mass timber exterior wall has to be non-combustible, with the exception of the water-resistant barrier that's on there. And then, already some projects that are being used for that. So, all right, so types construction. We actually looked at this already. Oh yeah, see, I knew I had this somewhere where it showed the 1A and the 4A getting matched up, and then the 1B and the 4B getting matched up, but we already talked about that. So, all right, allowable heights for your 4A, 4B, and 4C construction. What you'll notice a lot of places here is that 1B is going to match up with 4B for your allowable building height at 180. Not always, but for the most part, that's kind of what you see. And then you'll see that 1.5 ratio then to get from 4B up to 1A. And then you'll notice then that 4C matches up with the old traditional type 4, the 4HT. One other thing I do like to point out, in these mass timber buildings, one of the things that the Tallwood Ad Hoc Committee building, Ad Hoc Committee Committee wanted to make sure was that there was a good, reliable sprinkler system in these type 4 buildings. So a lot of people ask, well, why is there even a non-sprinklered option then in these height and area tables? But what you'll notice here is that if you just sort of go across that very top line, the non-sprinklered for A, B, E, F, M, S, and U's, you'll notice that what you've always been permitted for the old traditional type 4 buildings, which is now the 4HT, the 65 feet, if you don't sprinkle your building, you're capped at that 65 feet all the way across. So there's no advantage to not sprinklering. If you don't sprinkle your buildings, you're capped at what you've always basically had for height of these buildings. All right, number of stories. Again, you'll see a lot of correlation here between the type 1B and the type 4B, and then again you'll kind of see that same ratio of 1.5 times to get up to the 4A. And then a little bit of a ratio, kind of that same ratio number back down to get to the 4C. And then again, you'll also notice again that non-sprinkler line, you're capped at whatever you've always been permitted for the type 4. So yeah. For allowable areas, that one though, this was all just straight math. So they took the traditional type 4 buildings, multiplied it by 125% to get to the 4C areas, doubled it to get to the 4B areas, and then tripled it to get to the 4A areas. That was just all straight math across the board of how they came up with those numbers. All right, so one final recap here on the 3 types of construction. Type 4A, maximum height is going to be 270 feet. Your number of stories, 18 stories. Fully exposed or fully protected, I should say, mass timber. So you're not going to see any mass timber anywhere throughout there. And again, 3 hours on your primary structural frame, 2 hours on your floor, and then that 1-inch non-combustible topping on those floors. Type 4B, 180 feet maximum height, 12 stories maximum, partially exposed mass timber, 2-hour primary structural frame, 2-hour floor framing, fire resistance rating, and then that 1-inch floor topping as well, that non-combustible floor topping. Type 4C, 85-foot maximum height, 9 stories maximum, fully exposed mass timber other than those couple areas that I mentioned. No requirement for that floor topping, but still a 2-hour primary structural frame, 2-hour floor fire resistance rating. Here's all 3 of those kind of side by side. That's sort of the money shot. I showed this out in Michigan in December as well, but you know, all 4 of those types of construction for type 4 all together there. And we're coming up at the top of the hour. I've got about 10 more minutes here of stuff, but I'm going to run through these pretty quick because I'm sure you guys are getting kind of bored. So construction, occupancy separation in a 4A, 4 or 4B and 4C occupancy. There is a requirement to have at least 1 layer of 1/2-inch gypsum on each side of a required occupancy separation. So even though you can have some exposed areas, that's another area then when you do have an occupancy separation where you do need that 1/2-inch gypsum or equivalent. Same thing with incidental use separations. Again, that 1/2-inch gypsum required in there. Shaft walls, I think we've already touched on these a bit, but you need 2 layers of 5/8 type X on the interior, on the shaft side and the room side of shafts in 4A and 4B. And again, keep in mind that 4A is capped at 12 stories. And then again, the CLT is going to come up with the rest of that fire resistance rating. Type 4C, you need 1 layer of 5/8 type X in there. So if it's a 2-hour shaft, again, 80 minutes now is actually going to come out of that CLT. There's a requirement to seal mass timber. So 4A, 4B, 4C construction. Anytime that you have mass timber to mass timber elements touching each other or mass timber to other construction elements touching each other, there's a requirement to put some sealant or adhesive in there. That's not a fire caulk. It's not anything like that. It's really just to keep that air from that hot air and hot gases from passing between those. In the 2027 code, we got this successfully in there for Group A. we kind of restricted this down a little bit so you don't have to do it everywhere. It's really just where it makes sense. We took out if you have a fire resistant joint system, you don't have to do it. But again, that's all coming into the 2027 code, so that'll be a little bit ways off. But again, it might be a grounds for a variance for you guys down the road. There is a periodic special inspection of that sealant that we'll talk about. You can use mass timber for fire blocking materials in the code now. That got added into the list of fire blocking materials. There is a requirement for a redundant water supply once your 4A, 4B buildings get up over 120 feet. So if anybody in here designs a lot of high rises, you've probably seen this before. Once you get up over 420 feet, you need that redundant water supply. So a water pump coming in or a water supply coming in to a fire pump off of 2 separate streets. Well, again, 4A, 4B, once you get up over 120 feet, you also need that same requirement. Concealed spaces, I'm just going to jump through these real quick. 4A, 4B, you need 2 layers of 5/8 type X. 4C, you need 1 layer of 5/8 type X. 4HT, I mentioned this earlier, but again, you have 3 options. Sprinkler it, fill it completely with non-combustible insulation, or drop in or cover everything up with 1 layer of 5/8 type X. Same 3 that are offered in NFPA 13 for type 4 construction. Yeah, that's just a method on the concealed spaces. They did test concealed spaces with the fire tests, but we talked about the primary structural frame a couple times. There were some changes to the primary structural frame in the 2021 code that you should be aware of. So again, it's really just the columns, the structural members having direct connection to the columns, members of the floor construction having direct connection to the columns, and then members that are essential to the vertical stability of the primary structural frame under gravity loading. So we're not talking about wind, we're not talking about seismic, we're not talking about any lateral forces. It's just what do you need for that gravity loading. If there's any bracing or anything that's required for that, that's actually part of your primary structural frame now as well. Everything else is a secondary structural member. So when we get that 3 hours for the 4A or the 2 hours for the 4B and 4C, that's what we're talking about with the primary structural frame. So that got tweaked a little bit in the 2021 code. There's some requirements in the International Fire Code, but actually I don't think that's pertinent to Michigan, so I'm going to skip that slide. We talked about fire resistance design a little bit already, but again, 722.1 gives you again all the different wood or material specific ways of coming up with fire resistance design. We have the 722 is going to refer you to the NDS. The 2018 NDS for the 2021 code. We also have another document called our technical report 10, which is calculating the fire resistance of wood members and assemblies. Some of you may be familiar with that. It's sort of the supplemental document that we have. So again, chapter 16 of the NDS is going to give you fire resistance design. Reason that's important is, throughout chapter 7 there, you do when you do fire resistance of structural elements, you also have to include those connections, right? And a new section in the code is 2304.10.1 talks about that connection of fire resistance rating for protecting those connections in the 4A, 4B, and 4C. So you can test a connection as part of an assembly. If you're running a ASTM E119 or UL 263 test, you can do that connection in there. Otherwise, you can go through engineering analysis, and that's what we have in the NDS. So make sure that you are protecting those connections. Typically in the NDS there, what we have is, you can do some additional wood cover to protect those connections. You can do gypsum on there. You can do other approved materials or a combination. What you're seeing more and more, though, is obviously those hidden connections, which is going to use additional wood cover. Especially when you have, a glulam beam to a glulam column type connection, you're seeing a lot of that, especially when it's going to be exposed, having those hidden connections in there. So we also have our latest document, the fire design specification, FDS. We're trying to get that into the 2027 code, but for the designers out there, it's basically a fire design guide similar to the NDS, all for wood. All the stuff from chapter 16 is pulled into there. All the stuff from the TR10 is pulled into there. So a lot of great information in the FDS. That is an ANSI approved document. we've gotten it approved into some of the sections in the 2027 IBC coming up. That TR10 that I mentioned, though, for protecting connections, it's going to give you background commentary, some design examples of how to protect connections, also a whole bunch of information on the testing and where that stuff came from. So a lot of great information there. There is a requirement, jumping back to some of the code requirements now. Code officials, they do have a requirement to inspect connections, hidden connections, prior to wood cover being installed. So if you do have hidden connections in there, before they kind of cover those up, there is a requirement to have those inspected. There were some special inspections for MassTimber. This is the list of the table. You'll see it's mostly all periodic inspections, with the one exception for the continuous special inspection for adhesive anchors. It's really pretty similar to special inspections that you get for precast concrete type construction as well. So special inspections, I'll jump through that again. I already mentioned that there is a special inspection for the ceiling of MassTimber. All right, construction fire safety. This is the last thing here, and then I'll wrap this up. So while that building's going up, again, you've got some construction fire safety issues that you'll want to be aware of, especially for the contractors that are here in the room, but also for the designers as well. So International Fire Code, and this also is reflected in the IBC as well, in Chapter 33. Different types of construction here, but standpipes are going to be required in accordance with Section 3313. So as you're going up with the building, those standpipes have to be within 1 floor of the highest level of construction that you're working on, and then in at least one of those stair towers, right? Also, a water supply for the fire department operations as approved by the fire code official and the fire chief. That's a requirement in there. I'm going to stop here, talk about fire departments real quick. So the Michigan, everything that we're talking about here, the IBC stuff, that's all coming in for 95% of your occupancies that are out there. However, the Michigan State Fire Marshal's Office, they actually handle occupancies for inspections and permits and everything for educational occupancies and for healthcare occupancies. Unfortunately, that is covered by their own fire code, which is still on a much earlier version of NFPA, which does not have any of this stuff in there. Sandra and I actually met with them back in December. They are open to using a newer version of the NFPA codes, NFPA 5000 or NFPA 101, that has pretty much these very similar provisions in there. But again, if you have a education occupancy, or if you have a healthcare occupancy, and you want to start to use some of these provisions, start having that conversation with the State Fire Marshal's Office as early as you can. All right, the third item in there on construction fire safety is non-combustible protection. You need that within 4 stories of the level that you're working on once you have at least a 6-story building. So you'll see right here that the non-combustible protection is going up down there on those lower 3 stories. Before they can start working up on the next story, before they can get up to the 9th floor, they have to have that non-combustible protection on the 4th floor. So basically building that up, and that's just one layer. You just have to have the base layer. So if you need 2 layers or 3 layers, you just at least have to have that first layer on. And then same thing on the exterior of the building. That has to go up in the same fashion as you're going up if you have exterior walls of CLT. Some resources, I mentioned this MassTimber Buildings in the IBC book. That's out there. There's a PDF version, there's a print version. ICC does have special inspector certifications for MassTimber. We've got all of our standards out there. Feel free to use that stuff. I should put the FDS on here for a future one. Whew. All right, and that's all I got.